Hello everyone, good morning. In this video, I'll be presenting my solution for the artificial intelligence assignment given as part of our coursework. Let me quickly show you the assignment PDF so we can understand the requirements. So as you can see, we were asked to build and train artificial neural networks on the iris dataset, compare the models, measure the performance, and optionally build a GUI to test and predict. I have chosen to implement this completely in Python and I have built a user-friendly GUI to demonstrate the results. So let's go and look into the Python code. So I have structured my solution across 5 main Python files. So let me briefly explain what each one does. So the first one, this handles the data preprocessing, loading the data set, manually splitting it into the training and test sets, scaling the features, and one hot encoding the labels. And we do have 3 separate files for the ANNs. These 3 represent the 3 different ANN architectures. Each has a full implementation of the training function, forward propagation, evaluation, and prediction logic using only NumPy. And this is the main interface that launches the GUI. It allows the users to test the models on the iris test dataset or enter custom flavor measurements for prediction. So I have also used some helpful built-in Python libraries like Tkinter for the GUI and Scikit-learn just for data preprocessing like scaling and encoding. So let's now run our program and launch the GUI. So as soon as I run the program, the GUI is launched and we are able to see the 2 modes. Option 1, this is use iris test dataset, and option 2, predict the flavor from manual entry. So there is also an option to switch between the ANN architectures. So if we want to go with the 463 or 4573, we can switch between the ANNs using this drop down. So let's do a demo. So let's start with option 1. I'll select each of these 3 ANN models and we'll click on run. So first I'm going to run with 433 ANN, and if you see, the test accuracy is 94.67% and the training time is around like 0.10 seconds. And these are the training evaluation time and test evaluation time. So these are like more like uh, very minute, and this will be always like around 0 seconds. I mean, it's based on the data set we use. Since we have used a data set which contains only 150 data, so this is how the results are quicker. In case if we go with the bigger data sets, there will be a training evaluation time and test evaluation time as well. And let's go over to the 463 ANN, and the test accuracy is 93.33%, which is less when compared to the ANN1. And let's go to our 4573 ANN, and the test accuracy is same as the 433 ANN. And let's switch to predicting a flavor from the manual entry. So for the manual entry, I have included 4 text boxes: sepal length, sepal width, petal length, and petal width. And for the values, I'm just going to take some inputs from the iris test data set as well. So basically, as part of our training and testing, for training we have used only the first 25 data from each class, and the second 25 data are used for testing. So I'm going to pick a data from the second set. So for example, so this is where versicolor data is coming. I am going to pick one of the data from here, 5.1. So I am going to manually enter these values: 5.1, 2.5, 3.0, 1.1. So now I'm going to select the ANN433 and I'm going to click on the predict. So it correctly predicted the class as versicolor, and if I switch to the other ANN and predict, it's also predicting it correctly. Since we already trained our model using the 75 data from the iris dataset, it's able to predict the results correctly if I use the data remaining data from the set. So for 4573 also it's able to predict it correctly as a versicolor, and I have included a reset button here so that on click of reset all the values will be cleared and the output section also will be cleared so that we can go ahead and enter the input again. And if we want to again see the results from the iris test dataset, we can just switch to iris test dataset and we can switch between the drop down for ANN and we can click on the run. So I have run this particular results and I have captured the results as well, and this shows the results. So model 1 achieved a test accuracy of 94.67% with the fast training time and stable performance, while the model 2 gave a slightly lower accuracy of 93.33 even though it has more hidden neurons. Also, the Model 3, it gave 94.67 accuracy, which is like a same as Model 1, but with a deeper architecture and a longer training time. So overall, based on whatever the test I have performed, I can say the Model 1 offers a great trade-off between the accuracy and efficiency, while the Model 2 did not improve the accuracy, and the Model 3 adds complexity without necessarily giving a better result in this case. So even when I was running this ANN, I tried changing the epochs, I mean the running time for the ANN 3. So I'll just quickly show it here. So this is the ANN 3. So we are training this model for 1000 times. So I'm just going to change it to 500 only for the ANN 3 alone. Now I'm going to run the code again. So if you see here, the test accuracy increased for the ANN3 now. So basically, like sometimes the more we train the algorithm, it kind of overflow and it won't give proper results as well. Sometimes we should not train it very low as well. So it just shows like how much I have trained the algorithm. So when I take it as 1000, it is equal almost like algorithm. I mean the ANN1 performs better than all the other two. But if I train the model only for 500 learning runs, the algorithm 3 provides better results. I mean the ANN3 provides better results when the training is less. So thank you for watching. I hope this walkthrough gave a clear picture of how I approach and implemented this assignment. If you have any questions or suggestions, feel free to leave a comment. Thank you.